Now the angle of elevation is the angle formed by the horizontal and the line of sight above the horizontal. So this angle here in between these two lines is called the angle of elevation. Now theta is the symbol we use to represent the angle, just like we use x to represent a missing side length. Now the side length that's across from the angle theta is called the opposite. The side length that is next to angle theta here is called the adjacent. And the third side length is called the hypotenuse, because that's across from the 90-degree angle, but we won't be using that here. We're just interested in the opposite and adjacent sides. Now there's a special relationship that exists between this angle of elevation and these two sides, and that's called the tangent ratio, or just tan. Tan is equal to the opposite side divided by the adjacent side. Now you might notice that the opposite is basically like the rise, and the adjacent is the same as the run. So that means that the tangent ratio is equal to rise over run, which is just the slope. So that's the connection between slope and the angle of elevation. Now in order for us to use the tangent ratio in a word problem, we need to use a scientific calculator. And we need to make sure our calculator is in degrees. So I'm going to make a note of that here. Calculator must be in degrees. Now for example 1, it says a slide at a playground is pictured below. Now for A, it says safety rules state that the slope should be smaller than 0.75. Does the slide meet this regulation? Well, let's find the slope and find out. Slope is rise over run. The rise is 250 centimeters. And the run is 400 centimeters. Now, changing that to a decimal, I'll divide 250 by 400 on my calculator, and I get 0.625. And because this is less than 0.75, I can say, yes, the slide is regulation size. Now for B, what is the angle of elevation? What's the angle formed between the horizontal and the line above the horizontal? So this angle here. So tan of theta is opposite over adjacent. And we just learned too that tan of theta is the same as the slope, which is 250 over 400. Now, to find the angle, we need to use a special button on our calculator. It's called the inverse tan button. It should look like this. Tan with a little -1. So you might need to press second function on your calculator or shift tan in order to access this tan -1. So put tan -1 and 250 divided by 400 on your calculator, and you should get 32 degrees by the time you round it. It didn't tell us what to round to, so we'll normally round to the nearest whole number when we're finding angles. Now if you didn't get 32, then make sure your calculator is in degrees. Example 2 says, what is the angle of elevation for a roof that has a pitch or slope of 5 over 12? If we have a roof with a rise of 5 and a run here of 12, I want the angle of elevation, which would be right here. So setting up my tangent ratio, tan is opposite over adjacent. And opposite over adjacent is the same as the slope, which is 5 over 12. Now again, to find that angle, we need to use this button here, that tan -1 button on our calculator. So put tan -1, 5 divided by 12, and you should get an angle of 23 degrees. Now for the last example, it says a parking garage ramp should not have an angle more than 3.7 degrees. The blueprints of a parking garage show a ramp that has a 14-foot rise and a 200-foot run. Do the blueprints satisfy the requirements? Alright, so here we have a ramp that has a 14-foot rise, 200-foot run, and we need to find the angle, which would be right here. So now, setting up our tangent ratio, I'll fill in my opposite side to be this one here, 14, and my adjacent side to be right here, which is 200. So doing my tan -1 of 14 over 200 on my calculator, I get an angle of 4.0 degrees by the time I round. Now, since the ramp should not have an angle more than 3.7 degrees, then we'll say that no, it does not satisfy the requirements. No, the angle is too high.